Hello, today we are working on this assignment here. Circle Day 2, we are learning about arcs. So the first thing is I would like you to please read, please read the description of what we've learned. Please start by doing that. If you need to translate, make sure you do the translation. You can always copy it and paste it into another doc, into Google Translate to interpret it. But it's very important that you understand what we're doing. But again, basically what we learned about before is how to find the circumference of a circle, which is the distance of the whole circle, okay? Basically today all we're going to do is we're going to learn how to determine only part of the circumference of the circle, which is called the arc of the circle. So let's go ahead, and one thing you can do is you can click on this maybe to start, and if you need to interpret that, you can interpret it. But an arc, again, all it is part of the circumference of the circle. And so let's see what we have here. So here we have, I'm moving points A and B. As you notice, the whole circle is all the way around. So if I take this point and move it all the way around to the other point, it's going to be, well, they say 0, but if I keep going, it's going to be almost 360. Why? Because there's 360 degrees around a circle. So as this gets there, it's going to become almost 360, but it turns into 0 because it's on the same point. But the important thing is, what is an arc? Well, an arc is the distance not all the way around the circle, but just only part of the circle. So how much of what's the distance of this? Well, it depends on the degrees. So this is 138 degrees. Now, if you think the arc, or the circumference, let's pretend the circumference is 100. Let's pretend the circumference all the way around is 100. Well, what would it be if we have 180? Half of that. Well, if the whole circle is 360 degrees, and that's 100, then 180 is 1/2 of it, so this would be 50, whatever the measurement is, okay? Now, the arc length is basically going to be this formula right here. See what this says? This is the length right here. This is the arc they're measuring. This right here is a symbol for angle, okay? This right here is a symbol for angle. In this case, degrees. That's what we care about. So this is the formula we're going to use today, okay? So if our angle is something, we multiply times pi divided by 180 times the radius, okay? Because what we're doing really is we're finding the circumference of the circle, but we're multiplying it by the fraction of degrees that it is. And I'll show you an example. Okay, so that's one of the things. So let's go ahead and open up the assignment and look at the way the problems are set up. So let's go ahead and download it and then open it in Kami, okay? Okay, so here we go. This first question, number 1, is just a review question, okay? That's what it is. It's just a review. You've done this before, okay? You know how to find number 1. So number 1 says find the circumference of each circle. Well, that's the distance all the way around, and we have a radius. See if you remember. If you feel like you remember it, you can try it. Otherwise, if you want, I will show you the explanation. But if you want, you can pause the video, and you can see if you can find it, and then I'll explain it when I come back. Okay, so if we're looking for the circumference, you may remember that circumference is like C for circumference, right? Circumference is C equals 2 times pi times radius. Okay, and what is the radius? It is 6, so basically 2 times pi times 6. The 6 and the 2 are 12 pi. Now this is telling us to put it into the nearest tenth and use the calculator's value to find pi, so I'm going to get the calculator. Okay, so 12, I would go 12 times pi, which is second pi. Enter, and I get 37.69. 37.69, the closest would be D, right? Okay, so that's how that would go. Okay, so this is just a review. Hopefully you remember that pretty well. Again, today what we're going to do is we're going to go ahead and find the length of each arc. Arc is just a part of it. So if you see the highlighted portion right here, that's what we're trying to find. Well, the arc, again, is just like finding the circumference, except you're not going to find the whole circumference. You're not going to find 360 degrees. You're going to find a part of 360 degrees, which is just 315. So the arc is going to be the arc, I'm going to make that A, okay, is equal to the radius, so it's going to be 2 pi r times, this is the important part, times the 315 degrees right here, divided by 360. Why 315? Because it's telling us that this arc right here is not the whole circle, but it's based upon the degrees inside here that represents it. So this is 315, so that's why I have to multiply it by that. So we're going to go, the radius is 11, so 2 times pi times 11 times 315 times 360. So let me use my calculator. Well, let's see, so it's 22 pi, right, because these two are 22, times this. So let's start by going, okay, so the first I'm going to go 22 times second pi. That would be, enter. That would be what it would be if it was the whole circle. But now I'm going to multiply it by, and I'm going to go in parentheses, 315 divided by 360, parenthesis, enter, and I get 60.4. 60.4, which is going to be closest to C, okay? So that's how this works, okay? So if you want, you can try number 3 and pause the video, see if you understand how to get it, and then you can come back and I will go over it, show you how to do it. Okay, so if you were doing it yourself, this is the setup you should have got. It should be 2 pi times radius, which in this case the radius is 3, and then the degree of this arc right here is 240 degrees, so it's going to be times 240 over 360. So if you've got that, you can try to put it in your calculator and come back. Okay, if you did that correctly, I show B as the answer. If you get something different, please ask me about that. Okay. Number 4 is the same kind of question. We're still looking for the length of each arc, but here, instead of giving a circle, they're basically telling us what the radius is and then what the degree. Now, what does this represent right here? This 135 is the same as getting the information right there with the 315 or 240. So basically, it's the same exact problem. It's just that they don't show us a diagram, but they're telling us that the circle has a radius of 15, so we could get the total circumference, but that we only want 135 degrees out of 360 degrees. So if you want to pause the video and come back, I'll show you how to do that too. Okay, I got 35.3 when I used this setup right here, okay? So that's how you do that. Let me know if you have questions, if you're having troubles finding out how I'm calculating this to get that. Okay, so the next thing we're going to do is we're going to get specific type of symbols that let us know what we're looking for. It says find the measure of the arc or central angle indicated. Assume the lines which appear to be diameters are actual diameters. Okay, what does that mean? It means that if a line goes straight through, it looks like it is the diameter. But if it doesn't, like for example, from C to the point, that's a radius. Any line from the edge of the circle to the center is the radius. So we have 1 radius, 2 radius, 3 radius, 4 radius, but we don't have any diameters because none of these lines form a straight line. Let's see if we have a diameter. Oh, this is a good example. Number 7, U to S is a diameter. Why? Because it's a straight line and it goes through the point. So that's a diameter. But from SUP, this is not a diameter because it's not a straight line. A straight line would be about right there, okay? So that's something to remember. Okay, what does this mean? This means measure of EB is the measure of the arc from E to B. Okay, well, where's E? E is right here. So we're going to start here, and we want to go from E to B. Now, here's a very important thing. Do I go all the way around here from E to B, or do I go from here to here? Okay, well, since we only have this, it means it's called a minor arc, so we're going to go from E directly to B. We're not going to go through any points. Let me show you a different example. Number 6 has SQT, right? So we have S, we have Q, and we have T. So does that mean I go from S to T? No, because I don't go through, I need to also go through Q, right? I need to go through Q. So when you see three letters, you need to go the other way. So let me go backwards. So that means we need to go all the way from S through Q through T. So we're going to go all the way from here. Sorry, I'm trying to make it on the line. To there. That's what we're trying to determine. Not this, but all the way around for number 6, okay? So anyway, let's go back to number 5. Number 5 says we're only going through from E to B. If we were going this way, it would have to say ECB to let me know we're going this way, but it doesn't. So it means just E directly to B. So we are looking for this right here, which means we need the angle that goes from this radius, which hits B, from this radius, which hits B. So we need this angle right here. This is our angle that we talked about before, right? What is that angle? Okay, well, if you remember, a full circle has how many degrees? 360, right? That's all degrees. That's 100%, right? But we need this part. Well, one of the things that you see over here is you have 75 here, 80 here, 48 here. So what it's going to be is it's going to be 360 minus 75 for this one, minus 80 minus 48, and that's going to equal this part right here, or the theta, right? So use your calculator to do that, and let's see what we get. 360 minus 75 minus 80 minus 48 equals, so I get 157 is going to be my theta, okay? So that's what this is. That equals 157. So now I'm going to do what we did before in the previous questions, but here it's just actually asking for the degrees, right? The measure of the arc or central angle indicated. Oh, okay. So I just need to get the central angle. That's all I need to get here. So they're just asking for the degrees. That's all they're asking for. Okay, that's not too bad. Okay, so let's look at number 6. Now that you understand that number 6 is looking for S all the way around to T, maybe pause the video, try it, and see what you get for your answer. Okay, so what I see is we get from here to here is 95. Here to here is 60. Here to here, do you know what that is? Well, remember, this perfect corner is 90. This is 90, right? And then we get 50. So we're basically going to be 95 plus 60 plus 90 plus 50. So try that on your calculator. Okay, so when I did it, I got equals 295 degrees, okay? All right, so what next? UT, we're looking for UT. Let's see. Okay, so now we're looking at number 7, which is a measure of UT. So what is that? Well, it is just from here to here, but you might say, well, how do I get that? I only have 127, right? Well, remember, this is a straight line, so this is the diameter. Do you remember the diameter cuts a circle into half, so that means that this from here to here is half the circle. 360 divided by 2 equals 180, correct? So basically, we're going to have from here to here is 180, so we can go 180 minus 127 from right here, and that would be 53, okay? So remember, this is the diameter, and that represents 180 degrees. Okay, finally, you may want to try this one. I'm going to pause the video. You can try it and come back, and I'll give you the explanation. Okay, so we're looking for PUS. Okay, PUS is, let's see. So when we see a number here on the outside, it means this part right here is 110. So this is 110. And then we see a 50 over here, so this is 50. And so if we're going to try to get PUS, it's these two together. So 110 plus 50 equals 160. That's how you do that one.